Welcome to Hillsborough Community College's South Shore Center in Ruskin. This multi-purpose facility, which opened its doors in the fall of 2008, is the first structure in what is ultimately master planned to be a 6-building campus. It is also the very first community college in Florida designed and built using the LEED rating system developed by the U.S. Green Building Council. One of the earliest guiding principles in developing the master plan was to ensure that the campus was as environmentally responsible as possible. When it came time to construct the campus, the college administration, architects, and engineers carefully considered all options and placement and orientation of the structures. HCC was very progressive in its thinking. The building and the site were looked upon as a holistic unit. The slough, grade, and sun position were carefully considered in determining where to locate the building. The 60-acre site, located near Wolf Creek in Ruskin, was originally an agricultural site that absorbed rainwater. Knowing this, the site was designed to retain runoff water on the site. The 5 buildings in this first phase, while separate, are connected through a single roof structure, thus creating shade to increase the environmental quality of the building's occupants. The buildings are also oriented to the north to take advantage of the natural light provided by the sun without heat gain. One of the first things that you will notice on the campus is the parking lot. You will see there are 2 key areas, the white paver sections and the blacktop. The white pervious pavers work to keep down the heat island effect, thus reducing the ability of microclimates to form. The biofiltration system works by grading the paved lot toward the vegetated islands. This is reverse thinking of a typical parking lot where the runoff goes directly into the storm runoff. The biofiltration system works to remove oils and contaminants from the water. It functions much more efficiently than a standard stormwater runoff system because polluted water won't be running into nearby ponds and ultimately into Tampa Bay. The plants used on site are xeriscaped and therefore do not use potable water for irrigation. While many students will drive to campus, they are encouraged to bike and carpool. You will find special bike storage areas by the security office. There is also special parking for fuel-efficient and alternative vehicles. The building is designed to be efficient in its energy use, water consumption, and generation of waste that would be directed to landfills. Recycling is omnipresent throughout the campus. The water wall is designed to reveal the water collection system to the building's occupants. This allows the occupants of the building to follow the cycles of water collection, water use, and water reclamation. The multiple roof planes divert the water to the single collection location at the reflecting pond. The main water wall that collects the water from the roof allows water to fall through the scuppers. This permits the building occupants to see a part of the cycle of water. A synergy occurs with the collection and use of rainwater. There is no need for potable water. Potable water has an embodied energy with the use of electricity and chemical treatment. The water used for the toilets and urinals is site-collected rainwater that was not created through the municipal water treatment plant. 100% of the water used to convey waste is site-collected. Therefore, the cost for municipal water is lessened. Another synergy comes from the collected water being used for the irrigation of a few areas close to the building. Using this naturally collected water means that chlorinated water is not being introduced to the groundwater supply by our irrigation. All of the fixtures in the building are low-flow fixtures. This means less water is sent to the wastewater processing plant. Therefore, less energy is used off-site as well. This combination of innovative water technologies reduces the generation of wastewater, potable water demand, and energy use, while increasing local aquifer recharge. The interior, while state-of-the-art, holds the faculty and students as the first priority. The interior finishes were chosen for their low volatile organic compound, VOC, content. VOCs have been eliminated in order to help the occupants breathe easy. The raised access flooring has several attributes that contribute to the building's users. The floor supplies the air to the space. The cool air, as it naturally warms, rises to the above-ceiling return air plenum. The warm air that naturally rises helps the building use less electricity by using less fan power. The flooring also allows for reconfiguration at a later time. Electricity, communications, and future technology have ample space to be routed without demolition. The supply air and return air do not share the same space as in conventional construction. This is a much more efficient way to cool a space. Many of the spaces have movable partitions that allow for the reuse of the spaces without demolition, which saves time as well as resources. This allows the function of the campus to evolve over time. Whenever possible, a synergy that involves the glazing system and light sensors was used. The insulated tinted glazing allows light in while removing as much heat gain as possible. When enough natural light is present, then the lights slowly dim. This saves electricity in two ways. The lights use less electricity as well as create less heat when they are dimmed. In all, the building's construction and operation is more energy efficient. Over the base design, it is designed to save the college an average of 25% of normal energy costs each year. As the traditional energy costs continue to escalate, you can be sure the savings will grow as well. HCC's South Shore Center was designed to provide access to higher education for the surrounding areas. By building a green campus, we will not only realize great cost savings, but are also providing this community with an invaluable learning resource and demonstrating our commitment towards being responsible stewards of the environment.